Welcome back. Let's check out a new section of our Star of Security. We're going to talk about cross-site scripting and cross-site request forgery. And they're kind of similar. They have some overlaps. So we're going to talk about them together. You're also going to start noticing that a lot of these actually overlap as well. Some of the best practices here are also going to affect other parts of the star. So what is cross-site scripting first? Well, cross-site scripting occurs whenever an application includes untrusted data in a new web page without proper validation or escaping, or updating a web page with user-supplied data using JavaScript. Cross-site scripting allows an attacker to execute scripts in a victim's browser. And you can do a lot of bad things by doing that. Let's use a practical example here. Imagine our security playground was a blog post. And this blog post allowed for comments. And users can comment. Now, a bad person can come in and, try to execute scripts like we tried, and that won't work. And we've seen this before where we can try and insert scripts in here. Well, this was a blog post, and I did our old example, something like this. Remember, our image source, that's going to error, and it's going to alert 1. And let's make sure we close off the tab, click submit, and we've run JavaScript on our browser, but that doesn't really mean much. However, if this was a blog post with comments, by submitting this comment, other people viewing this browser can now go to this blog post, and because I've entered this comment, it's going to also execute in their browser. And the DOM is going to try and update and instead execute this alert function in a user's browser. And that's what cross-site scripting means. I can run code cross-sites to different sites from my browser. And what most bad actors would do is use a line like this. Window.location equals to some website that I created that's really bad website. And I'm going to send something called document.cookie. All right, so let's unpack this. I'm going to just remove this for now and just do window.location. And it shows me exactly where my URL is. If I go to a website like Twitter and do the same thing, or do window.location, I get the URL of Twitter. And I can actually change this URL and send people to different websites by just saying window.location equals. So the first part of the script is saying, go to this new website that I own, that is a bad website, and then I want you to send me the data that is the cookies. What is document.cookie? And this is something that we're actually going to talk about in the JWT sessions. But a cookie is a way for us, when we log into something, let's use Twitter as an example. When I log in here, Twitter now remembers that I'm logged in. If I refresh this page, I don't have to log in again. I have a session with Twitter. And a lot of websites, actually majority of them, will let you sign in with what we call a cookie, a random piece of text that I receive. And that piece of text is going to be attached to my browser. So every time I go to twitter.com now and I have that piece of text, the server from Twitter is going to say, oh, yeah, that's Andre. Yeah, you can let him in. And like I said, we're going to talk more about this in detail in the JWT and sessions section. So don't get hung up too much about it. But the idea behind it is that if a piece of text is the only thing that's allowing me to enter Twitter, then I can steal that. I can copy and paste that cookie, open up another browser, type it in, and log into Twitter. So I can log into Twitter without knowing my username or password. Pretty scary stuff. So if we go back to this example, all I'm saying is I want you to change the location of my URL. So go to this website, and I'm going to also send to my website this information, your cookie. So I can have a server that just logs out people's cookies, and now I have your information. If I knew that you were commenting on Twitter, for example, then I can steal that cookie information and sign in. And cross-site scripting is exactly that. It's used for session hijacking. That's what we call it. You already know how to prevent this. We sanitize inputs. We make sure that you can't just enter anything you want in our website's input. All right, that's pretty nice and easy. Let's talk about the next point. The CSRF, or CSRF for short, is cross-site request forgery. I know the names are pretty confusing. Don't worry, the main takeaway from this video is going to be at the end of how to prevent these. So you can always come back to it if you're confused. They are a little bit advanced and you don't need to know them by heart. Like I said, you just want to know how to prevent them. And don't worry, I have a slide just for that. So we have a problem. We have our client, and luckily for us, we know to use HTTPS when communicating. So we have this little tunnel that protects our data from third parties and people that are trying to spy on us. A client makes a request to a server that maybe gets the profile of the user from the database and returns it to the client so we can log in. And then sometimes we also talk to third-party APIs. Maybe we get weather information or we get our robots from a third-party API, and we make that request through HTTPS. So we're all safe, right? Well, as we saw with cross-site request forgery, if the server and the third party trusts the client, well, then we can use that cookie to log into server and database and get that user's session. So that's not the only thing that we need to do. In CSRF, or cross-site request forgery, we, as a bad person, create a bad URL that has malicious code in it. So you're most likely going to see this in something like scam emails, where they make you click on a link. For example, they'll have something like this. Let's clear this. Let's do a new bad piece of text. So this could be in an email just as text, or perhaps on a website that looks like google.com, but it actually has an extra L and has an A tag where you can click sign in or read more and takes you to this bad website. And over here, what they're doing is they're using query parameters to, and this is just an example saying, I want the account of the attacker and send the amount $100 to that account. And this is an example of a CSRF attack using the HTTP GET. We're doing a GET to a query parameter. If a victim visits this web page controlled by an attacker, and the victim is already logged in, let's say to their bank, because they've already set those cookies and the server thinks that they're already signed in and this is legitimate because we just made that person click on that link. So they're in the same browser that they're logged in with. Well, I just made the user, the victim, click on a link that sends me money. And this isn't just GET requests that you can do this with. You can also do it with POST requests using iframe, and that gets pretty complicated and outside of the scope of this course. So that's pretty terrible. How are we going to prevent something like that? Well, let's talk about how we can prevent it. But before I do that, let me do something cool. Let's try and attack Twitter. Let's write this piece of code, a fetch request to this website that actually, let me show you what it does. It's an HTTP request and response service. We essentially just output to this website whatever response we get, or where are we? Whatever response we get, and we can keep track of it. So let's try and do a post request. And in that post request, send from this website, from Twitter, my cookie of me being logged into Twitter. If I press enter, whoa, I get some errors. I get refuse to connect to this because it violates the following content security policy. Refuses to connect. We see that we have this content security policy that prevents me from doing it. And Twitter here is using a security measure to be like, no. We're not just going to send document.cookie, which is very important, to just another website so easily. So they have good security measure. And it looks like they're using something called content security policy. And all we need to do to set this is to just have it in our headers. Now, what does that mean? Well, let's just show you. I have my Express app over here. And let's just go to the get method where we just return hello world. If you remember, if I go to localhost, I have the hello world over here. Now in here, let's, before we send this, do rs, so response, dot set. And this might be different if you're not using Express or any other server, but the idea is the same. It'll be 99% of the code is pretty much the exact same. All you're going to do is give it an object, and this object is going to have whatever headers we want. Let's say that we want to have content security policy, and we're going to tell this website that the only places that we want JavaScript to be run, and let's use double quotes here just so we can use single quotes as well. Let's go like that. And it's going to be self, so our domain name, which is localhost for now. And also, let's say that we really trust Google API. So let's just do HTTPS and to the Google API so that Google, we trust it. They can run scripts. And let me just save that. All right, syntax error, hello world. We just have to add the bracket over here now. Let's save. All right, now check this out. If I go to hello world and I refresh, or go to network tab and refresh, if we go to localhost, we now see that we have content security policy, script source self, HTTP API, google.com. So we just set content security policy. That's it. That's how simple it was. And these headers look really, really overwhelming. And don't worry, these are actually a lot simpler than you think. As you know, with HTTP requests, we have different things that we can send, such as body, parameters, and we also have response headers. And I'm going to show you actually how to simplify this. You're not going to do this manually most of the time. Luckily for you, there's NPM packages that we're going to talk about later on in the videos where this is done automatically. But I wanted to show you just so you know how to set headers. And then finally, we want to make sure that this document.cookie can be accessed so easily. And by the way, I don't recommend using cookies. And there's, again, kind of a debate about what to use. So people might hate me for saying this, but I'm not a big fan of cookies just because it adds extra layers that you need to do to be secure. And I'm going to show you later on in the course, in the JWT and session video, how we can actually do this securely. But let's say you're using cookies on your website. Again, it's a very, very simple way to prevent this from happening and preventing CSRF, so cross-site request forgery. All we need to do is say that we want, actually, with Express, we can just say response.cookie, say a session ID. And by the way, this is exactly how a cookie is created by the server. saying, I just checked, your username and passwords match. Here's your session so that from now on, we don't have to check your password and username. As long as you send us this session on every request, I will check and make sure that it works for you. So in here, I'm just going to say that, and these are the two headers that we want to set for cookies. HTTP only, and we're going to set that to true, and secure is also set to true. If I save this, right, and actually I think we can only set it one at a time. So we're going to have to, let's close this like this, and we're going to do one more again, this time with secure true. Let's save and go back here, open up the tab. If we refresh, we have set cookie. Look at that. We have HTTP only. We have secure. And the cool part is, if we go to application and cookies, look at that. We have the cookies for the session. I think this is from a previous one, so we can delete this one. But if we refresh, we have the session. If I close this and refresh again, the session is back. Very cool. Again, don't get too scared about this. We're going to talk about cookies a lot more. I know it can get confusing, but this is all part of what we can make secure. And you know what? I think going to a slide and summarizing what we need to prevent cross-site scripting and CSRF might be the best idea. So what have we learned? Well, we already know this, right? We want to do client-side input validation for quick user feedback. Never let something like this work on your website, and never trust it. Always validate and encode user input before displaying, something that we've discussed a lot about. And by the way, modern frameworks like Angular, React, and Vue all do something called escaping characters to avoid this type of behavior by default, which is really, really nice. And the sanitized input is something that we're very familiar with. I also want to emphasize to not use the eval function in JavaScript. Yes, JavaScript has an eval function, and it's very, very dangerous. Don't use it. It is very rare that you would ever touch this. There's also something called document.write. So it's kind of like document.innerHTML, but worse. For example, if I go here and do document, I can't type document.write, and we do a script tag that has an alert of 1, and close that script tag. All right, it doesn't let me do it because I've just set the headers. But if I go to my other security playground that I haven't done anything in, let's refresh here and remove this. Look at that. I was able to execute just by using document.write, and I was able to enter a inline script. We learned that we should set content security policy headers. And don't worry, this is something that I'll show you a tool that makes it very, very easy in the set headers video. And finally, we want to set secure and HTTP only for cookies using some of the methods that I showed you. By the way, as with anything, for problems that happen all the time, there's pre-existing solutions and tools. And one of them to avoid CSRF is, well, this package. All we need to do is install it, require it, and then we can use it in any app that we want. For example, in Express, it shows you how to use it if you're using cookies. But like I said, I'm going to show you a better way than this, so don't stress about it. I know this video is a little bit difficult, but just stick with me, trust me. By sessions and token video, this video is going to make a lot more sense. Remember, HTTP only attribute prevents the cookies from being accessed by client-side scripting. And the secure attribute ensures cookie will be sent over the HTTPS connection. So both of them work together. Again, HTTP only says only HTTP methods can access the cookie. No JavaScript can. So that mitigates our cross-site scripting attack that we might be able to use. All right, we've learned a lot of new vocabulary here. This might be a video that you need to come back to, but I'm going to leave some exercises for you after this video to get a little bit more familiar and play some fun hacking exercises. I'll see you in the next video. Bye-bye.